All right, today we're going to break down a few really core concepts in software development. We're talking about unit testing, stubs, and drivers. So let's just dive right in.
Okay, to really get a handle on what unit testing is all about, let's start with a simple analogy. Think about how you'd build a car.
You don't build a car all at once, right? It's really just a massive assembly of these big, complex parts. You've got the engine, the body, the wheels, and each of those is a huge project on its own.
But let's zoom in a bit. If we take just one of those big components, like a wheel, you see it's also made up of a bunch of smaller individual pieces. You've got the tire, the rim, and then deep inside, you've got these tiny but absolutely critical little things like ball bearings.
And here's the key idea. You keep breaking things down until you get to the smallest possible part you can test all by itself. In our car example, that's one single ball bearing. You want to make sure that little thing is perfectly round and smooth before you even think about putting it into a wheel.
Okay, so let's translate this over to the world of software. A unit is basically the software version of that ball bearing. It's the smallest piece of code you can possibly test in isolation. We're talking about something really small, like a single function that just adds two numbers, or maybe a method that checks if an email address looks valid.
And that, right there, is unit testing. It's simply the process of checking every single one of these tiny little code units all by themselves just to make sure they do exactly what you think they do. Does your addition function actually add? Does your email validator actually validate? That's what you're trying to prove.
But this is where things get a little tricky. It brings up a really important question. What happens when you need to test one piece of code, but it depends on another piece of code that, well, it hasn't been built yet, right? How can you possibly test the wheel if the axle isn't there?
Well, the answer lies in a couple of really clever tools. They're basically temporary stand-ins, and we call them stubs and drivers.
So, first up, let's talk about stubs. A stub is like a dummy placeholder for a component that your code calls. Imagine it's like a stand-in actor in a movie who only knows one line. It doesn't have any of the real complex logic. It just gives back a simple, predefined answer so your test doesn't get stuck.
Here's a perfect example. Let's say you're testing a login function. Now that function needs to get user data from a database, but maybe the database isn't built yet, or it's just a pain to connect to for a simple test. So what do? You create a stub that pretends to be the database. When your login code asks for a user, the stub just hands back some fake user data you've already prepared. This way you can test all your login logic without ever touching a real database. A driver, on the other hand, is pretty much the exact opposite. It's a temporary bit of code that calls the unit you're trying to test. It basically pretends to be the higher-level part of the application that will eventually use your code, and its job is to give your unit the inputs it needs to run.
So, imagine you've written this really important function that processes credit card payments. Awesome. But the actual checkout page that a user would see, that part of the app isn't ready. No big deal. You can write a simple little driver script that just calls your payment function directly, feeds it some test data, and lets you make sure it works perfectly, long before the rest of the application is finished. So if you want to boil it all down, the real difference is the direction of the call. A driver calls into the code you're testing, pretending to be something above it. And a stub gets called by your code, pretending to be something below it that it depends on. It's all about who is calling who.
Okay, so why does any of this actually matter? It sounds like a lot of extra work, right? Let's zoom out and take a look at the bigger picture to see why this is so important in modern software development.
You see, in the modern world of software, everything is about speed and automation. Unit tests are the absolute foundation of that. The whole process is automated. A developer commits some new code, and instantly an automated system runs all the unit tests. If everything passes, great, the code gets integrated. But if even one little test fails, the whole thing's blocked. It acts like a security guard, preventing bad code from ever getting into the main project. But, of course, nothing's perfect. As powerful as this is, it's not some magic solution. There's a real trade-off here. You've got some amazing benefits, but there are also some serious downsides you have to think about.
So on the plus side, the advantages are massive.
You catch bugs really early when they're easy and cheap to fix instead of months down the line when they're a disaster. Your overall code quality just gets better and better. And, maybe most importantly, it gives developers the confidence to make changes and improve things without being afraid they're going to break the whole system. The tests themselves even serve as a kind of living documentation.
But there's the other side of the coin. This stuff takes time. A lot of time. Writing good tests is a real effort. And every time the main code changes, you have to go back and update the tests, which is more work. And you always have to remember, a simple stub might not act exactly like the real, complex system it's pretending to be, so you can still miss things.
And all of this leaves us with a big final question. In the real world, you're always fighting a battle between quality and deadlines. So the constant challenge for any team is finding that perfect balance. How do you decide when you've done good enough testing to feel confident, but without missing your deadline? Honestly, that's one of the toughest questions in all of software engineering. Thanks for watching.